T minus 30 seconds. T minus 20.
Falcon 9 secured. Flight pressures.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the Falcon 9. JCSAT section 10.59 is secured back.
Falcon 9 power telemetry is nominal.
Plus 1 minute and 10 seconds. We've launched from Space Launch Complex 40 at Cape Canaveral. We're waiting to hear the call out. We're going supersonic right now and passing through maximum dynamic pressure. Vehicle has completed the throttle down and throttle back up.
Stage 1 propulsion is nominal.
And you heard the words and the cheering in the background. Propulsion is nominal, a phrase we love to hear at SpaceX. We're currently beginning.
MVAC chill has begun.
There's the call out for the chill in of the MVAC engine, just like we did before launch for the first stage engines. We're now chilling in the turbo pump on the second stage engine with liquid oxygen, getting it ready for ignition, coming up in just about 35 seconds. The next major event that we're going to hear is main engine cutoff. That will come up at about 2 minutes and 38 seconds. You can see the ground cameras following the Falcon 9. The cameras on the Falcon 9 will also be used, bringing us images back from space, and a great view looking up the back end of the main engine. We're going to listen in as we go to main engine cutoff and stage separation now.
There you can see the main engine. We got confirmation. Our second stage has separated, and we have good ignition of our second stage as well. We'll be having a video of that for you in a second here. But right now, the good news is we successfully separated from our first stage, and that is back on its way to the drone shed, and we have a beautiful image of the engine valve for second stage.
Yeah, the first stage is actually continuing, because it's going so fast, it continues in this huge parabola, this ballistic trajectory, and out towards the drone ship in the middle of the Atlantic. It's quite a long ways. It goes up to about 200 kilometers in altitude before it starts descending again.
This is the same drone ship that we landed on not too long ago. Of course, I Still Love You, which, like we said earlier, is about a couple hundred miles off the coast of Florida.
Right, and let's not forget, of course, that view of the right side of that second stage, engine powering. And from the front end of the rocket there is the fairing separation. You can see the JCSAT. And you're hearing image here right now, because it's coming into the drone ship. We will show you when we pan right there, and that's a view from our drone ship in the Mid-Atlantic Ocean. And it looks like we have the planning. We have some planning. This was a very, very challenging drone ship landing for us to pull off. I've seen before, I don't know what this wanted to happen. second ignition too.
Yeah, that coast is again to get us continuing our parking orbit so that we can begin that second burn to get JCSAT-14 directly where it should be.
But yeah, that's our second stage engine.
And even though the technology is wildly similar, or largely similar, between the two vehicles, or the first stage and the second stage, the fact that one has to operate in vacuum and the other in atmosphere reveals some of the larger differences. So this engine bell, for example, is a lot larger than the engine bells of the 9 engines on the first stage. And that's because in atmosphere, which is about 14.7 psi, once the engine plumes expand enough such that they reach 14.7 psi as well, you start to get serious turbulent effects. In vacuum, you don't have that pressure, and so you can have a longer engine bell to continue extracting work. Now we've got 5 seconds left before the second stage starts to rotate. And what that does is it allows the satellite to begin stabilizing for that when it deploys.
Yeah, it's a bit like, think of a much faster example. We think of like a rifling of a bullet. When you fire the bullet, to spin that bullet, to align it and make it go very straight, we are very, very slowly, and you'll start to see the vehicle rotate from that view, spinning up our second stage for the gyroscopic stabilization before we deploy our satellite, the JCSAT, from the forward end of that. And we are about to separate, and we have a good separation. You can see it leaving right there. Goodbye, JCSAT. It's been a great mission for you.
Have a great trip.
So at this moment in time, JCSAT itself is going to begin its on-orbit activation. You saw that animation a little bit earlier. It's going to pop out its solar rays as well as the antennas. And our second stage is going to remain in that area as well. We're going to do some safety maneuvering with that vehicle too. So we still